Hello and welcome, class. Today we'll be building a functional application, namely a collage tool using Flickr and drag and drop. We'll use folktail and lambda and all sorts of functional goodies, learning about folds and applicative functors and monads and traversals all along the way. Now I expect you to already be familiar with currying and composition, as well as at least have dabbled with functors and monads in the past, so I won't be going too in depth, but we will be doing quick reviews. Okay, everybody grab your computers, clone from Git, let's get started. Okay, looking at the code here, we have a backend that is simply an Express app serving up one view, not even worth a mention. We will look at it later in the series. Our Webpack entry point is this main.js in the front end here, and it is simply going to render our app component to the main div. Now let's go ahead and look at our app component, which is the only thing I've done without you, and it is simply a component that has an error in its state. We can set the error, and if it's showing, it will appear at the top in a little paragraph. That way, in all the components, we can show an error if we choose. Now, let's go ahead and... Oh, you may be wondering what these comments are. Well, they're little type signatures to tell us what's going on. It's for our own amusement. There's no actual type checking going on here. Now, it says an error is a string, and down here, for show error, it's a function from string to a state change of error. Now, this error corresponds to the name in the state, and we're not actually in the state monad. No, not at all. We aren't even returning anything. We are just doing this so we see what's going on. We are going to change the state, and it's easy for me to read and grok. Okay. Let's start out by making a Flickr component, and we should be able to show error from within it. So we'll pass this little function in here, and we'll go ahead and make a Flickr component, Flickr, and let's go ahead and copy this whole thing as a template for it, and make a new src frontend.js flickr.jsx. There we are, and go ahead and rename things here, change within that, and we don't need to show the error. And what will this component consist of? Well, suppose we should have an input, and a button, and should say search button, and finally a div id results to show our eventual search results into. Okay, where to begin? Well, if I type into input, if I do an on change, I'd like to set some state, perhaps a term. So let's say this.term changed, and we can go into our state and give it a term of, let's say square return. Term is an empty string, and we'll give it a type term string. Okay, so we know that we have some state that's a term, which is a string. And let's go into our other function, term changed, and say term changed is a function from event to a state change of term. And I like to deconstruct my event right here in the argument, so I can see better what's going into it. So we'll say current target, right here, we'll assign that to t, and say this.set state, term will be t.value, just like that. That's all we need to do. Now, the next thing I think we should do is go ahead and be able to log this out upon clicking the search button. So let's say onClick this dot search clicked. Okay, and search clicked will simply log things out. So we're going to take an event, and we'll just leave the type signature unknown here, and then we'll say search clicked. And we are actually ignoring the value. We just pass in that to say we are ignoring it. And in here, we will say console.log this.state.term. Okay, looks like Webpack is angry with us. Let's restart that to make sure it's all happy and make sure everything's saved. And we'll give this a shot to see if it logs out our term. Okay, here's our input, and if we search for a spotted owl, a lovely spotted owl, it shows up right here, and we are able to log out our term. Okay, moving on. The next thing I'd like to do is actually do some kind of Flickr search here. Now, we are in a pure functional setting. This is all impure. This component is where we do our impure things like setting the state and rendering the UI. React allows us to do it declaratively at least, but is impure by nature. So I'd like to do all our pure things in a model. So let's go ahead and define a model. We'll pull Flickr search out from there. Dot model. Okay, and let's go make this Flickr search function. And it looks like we're going to pass in the term to it so we know what to search. So we'll say src frontend.js model.js. And we know we want to, right off the bat, module.exports is going to be Flickr search here. Okay, now how do we define Flickr search? If we look at the type signature, we'll have a Flickr search take in a string, which is our search term, and we will return something here. We know it's going to be a function, and usually with a function I'll start out with a compose, so I know it's going to start running functions in order here. We'll bring in compose from lambda. So compose equals require lambda. Did you have a question? Huh? No. Well then, please refrain from humming. Right. Now, the first thing I think we should do is make a URL from the term to a full Flickr string. And I just happen to have my buffer pregnant here with a Flickr URL, so let's do that. Let's call it base URL, and we will paste it in. There we are. And it has my API key. Don't abuse it, please. Now, let's go ahead and say, how are we going to replace this tags part? This is the part that does the search with our actual term. So, a function make URL equals t. That's our search term, and we're going to take string search term to a URL. And we can actually define a URL if we choose. We don't have to, but this is kind of fun. We can use URL and string interchangeably now. Okay, so there are a few ways to go about this. We can simply concat some strings. We can do ES6 replacement with interpolation. And this would look like, say we were to take a start and end here, and base URL split on this little tags placeholder here that I put into the URL. And that'll give us a start and end. We can go ahead and return our start plus our term plus our end. But I think there's a more fun approach here. And have you ever heard of monoids before, class? Let's go ahead and review them then. In programming, we often like to combine things. So here we are going to combine two numbers via addition, or alternatively, we could combine them via multiplication, or even by comparison. And just like that, we can do this with strings into Taco Bell here, or with booleans via conjunction or disjunction, and so on, etc. These are everywhere, let alone doing things like merging accounts and things like this. It'd be nice to make a generic interface to program against and have this idea of combination captured in one type that we could implement for any of our types here, and that is called a monoid. It has two methods we must implement: concat and empty. So for string, this might look like a addition and an empty string. And these just so happen to be the first two arguments to reduce. Oftentimes, if we have a whole list of strings, we could reduce them down into one by combining them, and starting with our empty neutral element here, the empty string. So we can write this function mconcat, which is basically reduce with its first two arguments already filled in. And this will take a whole list of strings into one. And we could do the same thing with numbers, but how would we combine them? We've already seen addition and multiplication and such. Well, we can give it its own type called sum, or product, or max, or min, and so on. We could do the same with booleans, with any and all, and this will know whether it should start with an empty and concat of the false and or true and so on. Now, these all work correctly in the same way because there are laws to hold. These concatenations are associative, doesn't matter how we concat them or in what order, and the same thing with the empty neutral element, it should act like identity, not doing anything. Now, if we have a functor, we can put our monoid inside it, and our functor will just become a monoid by concating its innards here. So we can make identity a monoid just by having a monoid inside it. Now, the same thing with maybe, but beware, sometimes there are different implementations that still hold the monoid laws. For this one, it could short circuit if it hits a nothing, depending on the implementation here. Now, we've seen a lot of these mconcats with sum and product, and it'd be nice to have a helper function called foldMap that will take in a list of normal values and lift them up into all or any or sum or product or things like this, and it will then call mconcat. That way, it will be able to concisely say what we can do with this. And the whole point of this is to be able to rewrite algorithms that take different types and combine them doing the right thing based on the type it gets. Okay, back to the code. So now that we know what a monoid is, we can go ahead and use mconcat here instead of plus, and we could just separate these with a comma, and it will reduce this string down into our new URL. We would bring in mconcat from our helpful library point-free fantasy, and that would work just like that. However, I'm going to use a much simpler approach, and just, let's do away with all this nonsense here, and just say, take our base URL, we will replace it, the tags part of it, with the term in the base URL. Just like that, nice and easy. I'll go ahead and bring in the replace before we forget here.
Excuse me, Mr. Frisby. Why are you teaching us about monoids if we're not going to use them?
Well, it's good to know all our options before choosing a solution.
But you made a whole presentation and everything.
One day, it will be the right solution, and you'll think, thank you, Mr. Frisby, for teaching us monoids while you had the chance, before it was too late. Now, what we should do, after getting the URL, let's go ahead and do an http.get, and we'll have to define this. Now, we can define an HTTP with a combination of folktales task and jQuery's get JSON. Let's go ahead and do that. We'll require jQuery, yeah? And we'll bring in task from data.task. This comes from a library called folktale. Now, the way to do this would be, let's go ahead and make a HTTP object that has a get function here, that takes in some URL, and it's going to make us a new task. So we say our signature is going to be our URL to a task of either error or JSON. And this error placeholder is for asynchronous errors. We'll take a look at that later. But for right now, we can think of it as a task of JSON. So we'll make a new task, and it works like a bluebird promise, where we take a reject function and result function, and we will merely defer get JSON URL, and on error, we'll reject it, and on done, we'll call results. Oh, I've got the E there. And that's all it takes, just a nice little task constructor. And notice this isn't doing anything, it's just doing a constructor here. Nothing will run. We are getting a pure task made, no HTTP at all. It has the HTTP inside of it, and we'll have to tell it to run from our Flickr component. So, now we know the type signature, we've got a task of either error or JSON. And let's go ahead, back to our Flickr component, and use it. Now, to get it to run, we have to call .fork, and that will split it off into its possible error here. So we take an error function. We could use this .props.show error. This was passed in, remember, from our application here, show error. And I'm not exactly sure what the Flickr response looks like, so let's go ahead and just console.log that on success. There we go, console.log x, and that will be just a test here. So fork will actually run the task for us in this part of our app, not in the model. Now let's go take this for a whirl. And I will search for a woodpecker. And we see down here it logs out our results. Let's take a peek at what that looks like here. And, this will never do. Let's do this one over here. Okay. So we get a object back that has photos and some meta information and a photo property that's an array, and each of these has a URL S, and we want to get to the URL S for each of the things in these arrays to return an array of URLs that we will use to construct images on the screen. Let's get to it. So, we can do this in our model. We would like to, let's go back to our model. Instead of returning JSON here, we'd like to return an array of URLs. That way, we can return the response we'd like, we can transform everything here in our pure model, and then our consuming component gets the beautiful array of URLs. And to do so, we'll have to map over the task functor to run this code, and we will say extract URLs. That's a nice little function here, extract URLs. Let's go ahead and write that. Extract URLs is going to be the composition of using prop from Lambda to get the photos, and then we will use prop again to get the photo array, and then for each of those, we'll map over all of those and get the prop URL S, just like that. Very nice. Okay, in this type signature, extract URLs, notice we are going to take in the JSON from our task here. JSON directly to our array of URLs. It does not take in a full task. And to do that, our map will unbottle the task, pass in its JSON, we will transform it all, and return us our URL array here. Now, does everybody understand?
Who made a functor?
Well, I guess if you're asking how it became a functor, we can review functors and then look at the task implementation. So just like with other functors, where here we can just map over our array to transform the value and stay within the array. In the just, we can map over this value and transform the value and stay within the just. And nothing just ignores it altogether, but it returns a nothing. And here we have a task, we can map over its value to transform it, staying well within the task here. And we use this little of helper here to lift something into the task regardless of the complexities of the constructor. And so we can do the same thing with, this number 2 and map over that and multiply it by 5, all staying within the task. So if we were to give this task a type, it would have type task, error, or number. And the reason for that is you can always have an asynchronous error, and we must know when we call fork what the type will be passed into the top function, the error function, or the other function, the result function. Now, getting to the constructor here, it looks a lot like Bluebird or some other promise library, but we're going to do something very different from a promise and hold on to these functions and not actually run them. So what it's actually doing when we map is we compose over it with the previous resulting function, and we just tack our function onto the end. And this gets back to the category laws of map.map acting like a composition. We can continuously map over it, building up a transformation that will eventually be run later on when we call .fork. And this gives us great benefit over promises and things like this because we can go ahead and work with a value, pass it to another part of our application, and none of it ever runs, and we can continue to work on it as if it's there, and then only run it when we like to. Now, for our application, we are going to start out with make URL, and let's say we pass in the term kangaroo. That will transform it into a URL, and then we will go ahead and make our task with that. And to get at the photos inside of it, now remember, there aren't actually photos here yet, we're just thinking of them as being inside our task at this point. We can go ahead and pass it into extract URLs by calling map, and that will pop open the task, pass photos into extract URLs, and run through the props, grab the photo off that, and then pass the array into the map there, and transform a bunch of URLs, and then that goes right back into our task, completing the bottom map, bottling everything back up, and that is what we will return. Okay, getting back to it, let's look at this, and make sure we save here. Let's get back to our Flickr component, and we know what we're going to do here. We'll finish this up by taking in some x's, and we will say this.update results on these URLs here. These x's is the plural of x, I like to do that, and it looks like we can just cancel this out here and not have to have a whole function. Let's use a first class function here. And update results will simply say we're going to take in our x's and this.setState results to x's. There we are. And it's a state change of results. And we'll have to give ourselves some result state here. Results is an array. And we'll say results is an array of URLs so we can see what's going on. And down here, we'll actually output some things here. Why don't we go ahead and output these URLs or the results right to the screen. This.state.results. Let's give this a shot. Alright. And if map is not defined. This happens frequently. Let's go ahead and head over to our model and make sure we pull in map from Lambda and also prop. I think we used prop here. Okay, it's all happy again. And we'll search for a lovely blue heron. And there they are. They show up on the screen. And all that's left to do is turn them into images, which is very nice. We can go here and back to our Flickr component. And instead of just logging out the results here, let's go ahead and say images. And we will make some images out of the state results images. and we'll say map each SRC into an image that has that SRC and a key. React likes to have unique keys here. And that should be all there is to it. Let's give it a whirl. There are blue herons. It just reloaded for us with a lovely surprise of these beautiful birds. Well, that wraps up today's class. Next time we'll be learning about folds and other techniques, building out the collage drag and drop tool. Okay, I hope to see you tomorrow. Good day.